Thanks for tuning in, everyone. I hope that this session will be useful to a lot of you, or at least provide you with some context for what's possible. Just a little bit of background about me. I came to UCLA to get my PhD in physics. So I have a background in computational plasma physics, and I got involved with a lot of high performance computing. So then I moved to work for the Office of Advanced Research Computing, consulting with faculty and staff and students at the university about research and educational projects. And now my time is kind of split between computational support and physics research. At the university, I helped set up some Jupyter hubs that the campus can use in classes, and I've helped out on some projects where faculty is setting up Jupyter servers to kind of service the needs of data science and statistics for people not just at UCLA, but at a variety of community colleges and high schools, actually, and other schools. So I'm going to talk about setting up a Jupyter Hub. At the beginning, what I want to talk about is kind of just a very short review of what Jupyter is, and kind of separating the concept of the notebook from the specifics of the platform. So you've all been working with the Jupyter Notebooks and the Deep Note, with the Deep Note service. Setting up a Jupyter Hub is essentially like setting up something that's like Deep Note, although the functionality is a little different. So I'll go over Jupyter, I'll go over some platform options, and then we'll kind of talk about what you might need to think about before setting up a Jupyter Hub, or for example, what you might need to consider if you're working with the IT at your high school or support staff, you know, if you have somebody else setting up a Jupyter Hub for you. And then I'll show you briefly how to set one up. It's actually rather easy to set one up on Google Cloud or other cloud resources, but it can get quite involved depending on how complicated you want the setup to be. So Jupyter, you're all familiar with interacting with the notebooks at the moment. The Jupyter project grew out of the IPython project, which was an interactive development environment for Python. Jupyter, the letters come from Julia, Python, and R. Those were the initial three languages that hooked into these Jupyter notebooks. And now you can hook in well over 100 other programming languages to work with notebooks. So you don't just have to use it with Python. If you're a fan of a different programming language, you can hook that into notebooks as well. And I've included a link here too, if you want to go and look at the range of programming languages. I think you can also hook in MATLAB and Mathematica and that sort of stuff into notebooks. Kind of interesting too, from a physics standpoint, the icon for Jupyter came from a page from Galileo's notebooks. So this is a page of one of Galileo's notebooks where he was tracking the motion of the moons around the planet Jupiter. So the spelling Jupyter here is different than the planet Jupiter, but the icon, you know, you have your three languages, Julia, Python, and R, which are orbiting around this ecosystem. And really kind of, it grew up around the Jupyter Notebook. So the Jupyter Notebook is the central component of the project as it was being developed. So the idea is, just like in a lab notebook, you might have notes that you put in, as well as observations and data. Inside of your Jupyter Notebook, the Jupyter Notebook you access through your browser. So it's a browser-based environment, but then you have sections which are text, you know, sections where you can put in equations or other multimedia. You have sections which are code and which produce the output. So really this entire notebook, it's not just to do programming, but it kind of allows you to craft an entire narrative around your computation, which is in particular why it's very useful for education, because you can combine the text and equations and interactive media along with the programming cells. You can control the workflow as somebody works through the notebook. You can document this computational process. And kind of the combination of all of these elements then can lead you to the novel understanding that you're looking for, as well as the hands-on exploration. So it's not just a static web page that you're looking at, it's very interactive and hands-on. Getting a little more detailed about this, you as the user are interacting with a notebook file, but really what you're interacting with is your browser tab. So there has to be a way to synchronize the flow of information between what you're typing into your browser, what exists in this file called the Jupyter Notebook file, and then what's called the kernel, and the kernel is what's executing the commands of the programming language. So when I talk about hooking in different programming languages into the notebook, that's hooking in different of these kernels. There's a Python kernel, there's an R kernel, there's a Julia kernel. All of these kind of have to be installed separately in order to get the notebook to execute commands in a particular language. Kind of sitting at the center of this is what's called the Jupyter server. So there's a Jupyter Notebook, there's a Jupyter server. You can run Jupyter on your own computer. And when you start Jupyter on your computer, it starts up a Jupyter server on your computer. And that Jupyter server allows you then just to open up a browser on your own computer. And the server synchronizes the flow of information between your browser, between the notebook file, and between the kernel. And then when you execute, so say you're in your browser and you execute a cell, that sends information to the server sends the programming command to the kernel executes that programming command and then sends the output back to the browser. Jupyter Lab is in a sense a different technology. So if you run Jupyter on your own computer, maybe some of you haven't seen this. So you've just been interacting with DeepNote. DeepNote, has its own browser interface for working with the notebook, which shows up kind of in your main window. And then on the left or on the right or at the top, you see different menus. If you just interact with the classic Jupyter environment, the content of the notebook will take up your entire browser tab. That's kind of the classic Jupyter environment. Jupyter Lab is the next generation user interface. So the Jupyter Lab has a file menu on the left. It has different tabs. This entire view here would be inside of your browser tab. And then you'd have these menu items at the top. You'd have different tabs for files that are open. You can execute different notebooks and view them side by side, as well as markdown files, CSV files, and a variety of different file formats. JupyterHub now is a way of serving various of these Jupyter Notebook servers to individual users who are logged into the system. So just like with DeepNote, we all log into this service at deepnote.com. So we all have our own account. We can all have our own workspaces. We can all have our own set of files, and we all have our own set of permissions for what it is that we can or can't execute. When you set up a JupyterHub is something similar. There's a variety of hardware infrastructure which can be variable as far as what is actually running this, but you can think of a JupyterHub like a web server. And that web server launches up an individual Jupyter server for every user that logs into the hub. So you might have 3 students here who are all on their own computer. They might have different operating systems on their own computer, or this might be a phone or a tablet, but they all access, they open up the browser on their computer, and they would log into the JupyterHub, and the JupyterHub will launch an individual server for each user, which is specific just to that user. So there are different ways of isolating environments, controlling file permissions and that sort of thing. But that's essentially what the JupyterHub is. there are a variety of different notebook platforms that you can use. The one I'm talking about is just setting up a JupyterHub on some hardware of your choice. DeepNote and Google Colab are additional platforms for hosting notebooks. There are a couple others that we haven't talked about, CoCalc. 2i2c, you might in particular be interested in investigating because they intend to provide computational support for people who don't necessarily want to set up a JupyterHub on their own, but that are interested in having a JupyterHub of their own. There are also alternative notebook formats. Some of these have different approaches for how the computation is done inside of the notebook. Google Cloud Service, not Google Cloud, but just cloud services in general are developing their own infrastructure to support running Jupyter Notebooks, because Jupyter Notebooks are used in actually at quite a wide variety of different companies for a variety of computational work. AWS has their own set of kind of Jupyter services. So does Microsoft. And then you get into additional interactive notebook kind of environments. But specifically, I'm going to be talking about JupyterHub. So JupyterHub is actually just a Python package. You can access the GitHub repository for JupyterHub software and basically install it with Conda or with pip. You would install the JupyterHub software on your computer, and then it's actually relatively easy after you install Python, and you have to install Node.js as well for the JavaScript, because the JupyterHub's software requires both Python and JavaScript. But it's only a couple lines before you could actually get a JupyterHub up and running on your own computer. There's optional software which you can also install that kind of sits at a little bit of a higher level. So this is something like those, the Python or the Julia or the R kernels. This is all optional software, so you could install a kernel that allows you to interact with C or C++. There are all the Python packages that you can install that are specific to Python. You could install customized software on top of it. You know, all this stuff can make things complicated, but it's entirely optional. Kind of at an even lower level, there are ways that you can control the environment. I won't talk a lot about these because this is for coming up with a little more sophisticated system than you probably want. But Docker is a way to specify, in a sense, something that's like a virtual machine that's inside of your computer. So you can specify exactly what the operating system and binaries and Python packages are inside of the user environment very specifically. And then when your user logs into the JupyterHub, they can only access specifically what it is that you've installed for them to use. That's what Docker is useful for. And then Kubernetes and Helm just help you kind of orchestrate how Docker works. But as far as computer resources, Jupyter can run on quite a variety of things. So you can install it just on your own laptop or your own desktop machine. You can install it on a cluster, on kind of large clusters, and on cloud services. If you want to set up something for your students, unless you're working with IT staff, I think that the easiest thing to do would be to do it on cloud services. And cloud services also have the advantage that you can spin things up and spin them back down relatively simply. The disadvantage is that it might be a little more costly. It might be a little more costly than just spinning something up on your own desktop if you want to. But so now I'll get into some considerations that you probably want to think about if you actually want to set this up yourself. One is who's going to configure it and oversee it and maintain it. Who's going to interact with the IT staff. Hopefully it's not as hard as herding cats. But so I've listed, you might interact with your IT staff. There are people like myself or others who I would encourage you to reach out to if you have questions about this. I'd certainly be willing to help you out if you have questions about this process. I would likely be able to find other people, particularly in the Jupyter and JupyterHub communities, who are just interested in open source development and interested in helping out people who want to run this software. And there's certainly professional help out there too, if you want. One thing that can be useful is to keep in mind also is that this entire process can be split into separable elements, by which I mean you can set up a system yourself, and but as far as the configuration and the maintenance, these can be handled by separate people or by a team of people, or you can even have a student, a student that you trust help you out with maintaining the system or kind of dealing with day-to-day tasks. Okay, one thing you have to think about is what resources do you have access to? So there are a variety of different hardware infrastructures that you could install this on. To some extent, this depends on how much you want to deal with the nitty-gritty detail of getting things installed. But you probably also want to keep in mind what computational resources it is that your students need or that they have access to and that they'll be using to access the hub. So what do you really need to have access to? In a little more general sense, you have to know how many CPUs you might want to access. You need to know the amount of memory and the size of the files. So a general metric is that the CPU constraint isn't very large for running Jupyter notebooks. That's because when you execute a Jupyter notebook, the usage is rather intermittent. The CPU only has a high load when you're executing the cell, and it typically doesn't take very long to run the cell. So unless you're really getting into more heavy-duty numerical computing, the constraint on the CPU isn't really as much of a concern as dealing with the RAM. So the amount of memory is a little more of a constraint. The very general approximate estimate for this is you want about 1 GB of RAM per student. And you do have to keep in mind the size of the files and the disk space that's required. This is highly variable, so it just depends on the size of the data sets that you want the students to have access to. It depends on if you want all of them to have their own copy of it. Usually this doesn't get larger than about a couple hundred megabytes per student, but this really depends on what data you want your students to work with. Something else you have to think about is how are your students, what web address are they going to go to? So do you want something that's publicly available or private? You have to keep in mind that you want it to be relatively secure. So you don't want anybody out there logging into your JupyterHub. So you have to set up accounts with usernames and passwords. You have to keep in mind whether you want to restrict access so students say can't access it after they're done with the course, or that they can. It is possible to integrate this with other software like Canvas or Blackboard. That involves a little more work. And you want to keep in mind any restrictions on web traffic. So for example, what kind of external sites should students still be able to have access to when they're inside of the JupyterHub and working with the notebooks? So can they pull in data from Google Sheets? Presumably yes, to some extent. But then, if there are restrictions about them accessing other sites through the JupyterHub that they access, you might want to keep that in mind. You also want to keep track of the languages. What I'm going to show you is how to set up Python, and kind of a very simple example. But you also want to keep in mind how much effort you want to put into specifying the environment for the students. So when we've accessed DeepNote, we've been using NumPy and Matplotlib and Pandas. These won't be installed by default in the JupyterHub example. So you would have to set up an installation, or like an installation of these packages yourself. The possibilities are very exciting because Python has really good packages for a wide variety of things to do, but the dependencies can be somewhat complex. So that's something to keep in mind. And then you want to keep in mind how much is it going to cost. So, you know, if you're restricted by a certain budget, you have to know that going into this, and you want to keep in mind what kind of budget you want to spend on this. So the example that I'll show, you'll see on the webpage where it spins up what the cost for what I spin up is going to be. But it's greatly dependent on the amount of resources that you require, you know, how much person hours you want to throw into it yourself. That kind of might be, you know, an implied cost, as well as how much staff effort you want to put into it. So I've kind of been talking a bunch, and I think it's a good time for me to jump into just setting this up so you can see it. Are there any questions before I do that? Okay. So what I'm going to be doing is I'm going to be setting up something called the littlest JupyterHub. After I do this, I'll talk about some options. So the littlest JupyterHub, generally speaking, this is good if you have on the order of 50 students or less. So it's just going to set up a JupyterHub that on that order of people can access. It's just going to be running on a single Google Cloud instance, which is, you can think of like a single computer. And I'm going to be following along with the instructions that are at this particular site that I've linked. You don't have to look at that, and you don't have to follow along with these commands. I'll just go through it and show you an example of setting it up. And then I'll set it up so that all of you can access it. All right. So the first thing that you need, I'm setting this up on Google Cloud, so you would have to have a Google Cloud account. It's not very hard to get. You will have to give them some kind of billing information. If it's your first time signing up, they will give you some kind of trial credits to test things out if you want. This page, so do you see the Google Cloud Platform page? Yeah, okay. This is just a general page for kind of a dashboard for this Google Cloud project. If I go up here and click on this menu, there's quite a lot that you can do with Google Cloud. So you'll see a lot of options that I'm not going to talk about. And actually, so this is running a little slow. I'm going to stop my video, just hopefully so that what I'm going through is a little more interactive. So the first thing that I'm going to do is I'm going to come down to the compute engine and launch a VM instance. So this is a virtual machine. If you're coming at this for the first time, you might have to enable the billing. I can't remember at what stage it's going to require you to enable billing on this, but it might require you to enable the billing. But on this page for the VM instance, I'm just going to come down here and I'm going to create an instance. And what this is going to allow me to do is to create a virtual machine. And on the virtual machine, we're going to install this JupyterHub, and we're going to access it through an IP address that gets set up. So this first page is just going to allow us to customize what's being started. Here on the right, by the way, you can see what the monthly estimate is as far as the cost. I'm going to give it a name, instance opt-in. So you want to give it some name so that you can recognize, you know, you don't want multiple instances starting up and then you forget what's what. So we give it a name. I'm going to come down here under the machine type and actually under the series. There are quite a wide variety of different options for the CPUs and for the memory that would start up with this instance. So this might be some place where you want to try and estimate, you know, if you have a certain number of students, how many, you don't really have to worry about the CPUs, but you might want to say have a fifth of a CPU per student. And if you want a gigabyte of RAM per student, let's see, so we have 10, I think we have probably, I want to say we have on the order of 15 people that are attending here, maybe a little less. So I'm going to say I'm going to start up something that has, I'm going to go to the high mem. I can start up something that has 2 CPUs and 16 gigabytes of memory. That's probably sufficient. And then it will recalculate the price. It'll tell me over here, you know, as you get more CPUs and more gigabytes of memory, you're going to change the price. So it tells me it's about 11 cents an hour to run this. If I run it for the entire month, it'll be $80. And that's also dependent on the persistent disk, which is attached. So you can think of this like your disk drive. This is going to have a 10 gigabyte disk drive attached to it. And let's see, so I'm going to come down here as well. Most of this stuff you can just leave default. If you wanted to change the size of the persistent disk, you could change it here. You can also change, by the way, what kind of disk is available. By default, it's just this thing called a persistent disk. You could also have, for example, an SSD disk, which would allow you to have faster access times for the disk. Persistent disk is something I've always found to be sufficient. You do want to allow HTTP traffic and HTTPS traffic because you're going to have your students accessing this through a website. So you have to allow the traffic through the web. You could, by the way, also start up GPUs if you're interested. And I think I might have, let's see, did I skip over a step? Boot disk. I do want to change the boot disk. You can see right now there's something called image, which is Debian GNU Linux 11. I want to change this so it's an Ubuntu operating system. This again, these steps are all inside of the directions. So I'm just following exactly what are the directions on that particular website for the littlest JupyterHub, although there is a lot of customization you could do in here. Here also is where you could change the persistent disk to these other disk types. If you wanted to, you could change the size. I'm going to leave it how it is. And I'm going to say, so I'm going to select that for the disk. I also want to change the identity. This is more of a particular detail, but you don't want a service account to be attached to this. Let's see. And then there's something else which I want to change with the here. So under the management, you do want to have a startup script included in here. And that's because something needs to bootstrap into the virtual machine in order to get the JupyterHub software installed. And I'm just going to copy this from the instructions. So under the admin name, I'm going to add bwinjum. This is going to be my username when I log into the JupyterHub that gets created. the way it's initially created is it's going to set up some usernames. And then the first time that a user logs in, the user can set their password, and then that'll be their password moving forward. So at the moment, there's no need to specify a password here. I just specify that I'm going to be an admin. So I set whatever username I want for that. And then that should be done. And then I could click on create. So it's going to take me now to a page where it's going to show me the instance name. And it's going to do some swirly things here, which when it's starting up, eventually it's going to pop up with an internal IP and an external IP. And the external IP that gets spun up is the IP that I'll be able to paste into my browser to access the JupyterHub. So even though this IP address has popped up, it's still going through some installation in the background, because the instance itself has spun up, but the JupyterHub software is likely still being installed. So that might actually take a couple minutes here. But I can come here, I can copy this to my browser, to my clipboard, and I'm going to come up here. This is the particular IP address that got started. So I'm just going to try and go to it and see what it shows me. Yeah, at the moment, it's not showing me anything, and that's because it won't actually show me anything until the JupyterHub gets fully installed. What I'm going to do also, by the way, is kind of skip ahead with some of the instructions. And I'm going to set this up so that I can have a domain name pointing at this. So if you want to set this up on your own, if you have some domain name in mind, I could do like winjum.com. There are a variety of web hosting services out there. I use GoDaddy just because it's relatively easy and cheap. And all I need to do is, all I've done before is just kind of buy some domain names with this, and then I do some settings on my own. So I already have this set up for something called Pixie, which is for our computational plasma physics group. I'm going to just log in here. And the reason that I'm logging into this is because, well, for one thing, you probably want to give your students a domain name rather than an IP address. This could be something of your choice that's just a string of characters rather than the string of numbers. When you have your domain name, then you have to have some way to point a domain name to the IP address that Google spins up for you. So this is the 3.115.200 is the IP address at which this particular Google Cloud instance is accessible. And I'm going to use GoDaddy. I can add a domain, I can manage this DNS record inside of the account. If you create something called an A record, then you can point something which is the string of characters to a particular IP address. I'm just going to let this start up. Right. Okay, just to go out to load. So there's see that there are A records on here. For example, jupyter.pixie.org will point to this particular numerical IP address. CNAME is a way to point a string to another string as far as addresses go. You don't really have to worry a lot about this, but you can add something which is an A record. And I'm just going to say this is a opt-in JHub. Oh, actually, I'll say JupyterHub. And I'm going to say it's going to point to the numerical IP address that Google Cloud gave to me. And I'm going to add that record. So now I can in my browser, I can put in opt-in jupyterhub.pixie.org. That's the domain name. And it will redirect me to this particular IP address. For the moment, I'm just going to reload this page. And you'll see here's the JupyterHub that got spun up. So if I enter the admin username that I put in, and I can just specify the password that I want now, it can be something of my choice. So it's put me into the classic Jupyter environment. And this is where I could start up notebooks and run the notebooks. I could also start up Jupyter Lab if I wanted to. I'm going to go through just a couple more installation steps, and then I'm going to give all of you access to it so you could try logging in just to see what your environment is like. Let's see. Adding more users, install. Well, actually, I think at this point, what I'm going to do is, oh wait, let me try going to, or there are kind of two simultaneous things that I'm going to do, or I'll say three. One is that once you spin this up, you'll want to change it from the HTTP to HTTPS. And that's so that the information that's sent for logins and passwords gets encrypted as it's being sent over the network. At the moment, you can see my web browser is telling me this is not secure. So there are directions in here in the instructions for installing this that tell you how to change it so that it has the HTTPS. And I'm going to look those up really quick, so here I can show that to you. Some of these do require that you interact with the terminal inside of the environment. So I'm going to go back to my Jupyter server. And for those of you who haven't seen this before, you can access through this new button. You can make a new notebook, but you can also open up a text file window, a folder, and a terminal. So it's going to open up a terminal window, and I need to use some sudo commands to change the configuration of the JupyterHub. There are actually a variety of different things that you can change about the configuration. I'm only going to do this one. I'm putting in my own email. Let's Encrypt is a free way to set up this HTTPS for your website. And then I have to put in the domain name that I chose, which was opt-in JupyterHub.pixie.org. And then spell JupyterHub. So once I've set this, you can actually check the configuration of your JupyterHub. It should have the information. It's true, that's fine. And then you have to reload it because you have to reload the settings. It's probably going to kick me off because it's resetting this from a secure site to from a not secure to secure site, and it's reloading the proxy. So what that means is how I'm accessing the web page right now is getting reset and restarted. I'm going to open up a new one, which is so now you'll see it doesn't give me the warning. It just has the sign-in page. And I can use the same username and password, the password that I set up before. And I still have the running terminal. Which I'll exit out of this after it loads. And now adding user accounts. So when you set this up, you'll want to give user accounts to your students. You'll have complete control over this through, if you go to the control panel and then you have an admin panel. I set myself up as the admin panel when I was starting up the instance. And then I can add users here. So let's see. So I'll just use the first name of everybody that I see here on the windows. If you want me to change your name, you're welcome to send a name here in the chat, a message in the chat. Jennifer. Let's see, is there anybody on this, inside of this that I didn't add in this list? I think I got everybody. So I added you all, and now try going to the page that I pasted into the chat, and you should be able to log into this JupyterHub. You can see, by the way, when people are logging in. So if you have any trouble, let me know.
What am I putting in as a password?
You can choose whatever you want as the password.
Just whatever.
But,
okay.
Yeah, but then you'll have to remember what you put in because that'll be stored as your password.
Yeah, I won't know. Okay. I'm the worst with passwords.
Let me go back here. People are welcome to interject if you have trouble, but I'm going to go here to my server, and I'll just upload. So something else that I want to show you is what you might need to do if you want to install packages. So let's see. I think I have one of the notebooks here from the first day. So here I've uploaded the first activity, falling through the earth 2, inside of my environment. If I open this up, I'll execute the first cell, which is importing the libraries, and you'll see that I won't be able to import them because at the moment NumPy I can't remember what else got imported, but probably NumPy and Matplotlib aren't installed yet here. I'm just going to wait for this to start. So I can come through and I'm going to select the cell and I'm going to execute it. And it'll tell me it can't find NumPy and it can't find Matplotlib. So this is something else that I mentioned you want to keep in mind is what particular packages you want installed for your users. If you want to install new packages, you would come back here to the terminal or open up a new terminal. And then, for example, you want to do this with the sudo and -e. This will help to install it for all of your users. And then I'm going to use conda install. And I'm going to say conda install NumPy, Matplotlib, and then it'll go through the process here. If you tried opening up this notebook on your own, you could see that you couldn't import them. After I finish with this conda install, it should be installed not just for me, but for you as well, for any users that are accessing this JupyterHub. So this is one convenient way, by the way, to make sure that all of your users have access to the same installed packages. I wonder if I should have given this the conda forge. So you'll have to deal with some installation things yourself, if you have complicated packages that you want to install. But these ones shouldn't be too hard to install. It'll just take a minute or two here. But once it installs it, then you all have access to it without having to install it yourself. Although if you're in the notebook, you will have to restart the kernel or quit your notebook and open up the notebook again in order to have it recognize that the package is now installed. So I know this has been recorded and you can come and look back at this later, but does anybody have questions about the steps I was going through?
I would definitely have to watch that again.
Mm-hmm. Well, and fortunately, it's on that web page that I linked in the slides to. That has very detailed and like written instructions for the steps that I went through. So that's useful too. And then I'll just let it go through its installation here. And maybe just open up this in a separate tab so you can see it. So what I linked to is the landing page for what's called the Littlest JupyterHub. The page that I was going through is under installing on Google Cloud. And if you open up the installing on Google Cloud, you'll see a description of all of the steps that I was going through, along with a lot of handy graphics. And as you can see, that there's a lot of other stuff on this page as well. You can look up the how-to guides. Under the how-to guides, for example, is what I mentioned about enabling the HTTPS. On my slides, by the way, after that one for that said, let's do this ourselves, I've included a link to this particular page on HTTPS, because you'll definitely want to do this if you're setting it up for your students to access. You don't want to have it without the S. And then I've also included a notebook to their page on sharing notebooks and files, because I'm sure you'd want to know the ways that you could distribute notebooks to your students as well. Actually, let me just click on this. So there are a couple different ways that you could do this. Let me check, by the way, that it's probably not visible on the screen. I need to put yes, I'm going to install it. So it's going to go through and install those. One way that you can distribute notebooks to your students is with what's called NB Git Puller. This is kind of shorthand for pulling files from a GitHub repository and then taking the students directly to the JupyterHub with those files pulled into their directory. So if you have, for example, well, maybe that's a little more involved than I want to show at the moment, but you can create a link. If you put all of your files into a GitHub repository, then you'll have a web address for your repository. You have a web address for the JupyterHub that you've created, and you can combine those two together into a link. So there's a specific web page where you can create this link for NB Git Puller, and then you just give a link to your students. And when the students click on that link, it will take them directly to the JupyterHub where they'll log themselves in. And once they log into the JupyterHub, this NB Git Puller package will clone the files directly from the GitHub repository that you set up and copy those files into the students folder. So then the students won't have to worry about downloading and uploading files or trying to do a Git clone by themselves. They'll just be taken into their folder with the files in it. Option 2 is to actually upload the files yourself to a shared folder on the JupyterHub that you've created. So this is another option. You can simply create a shared folder for all of the users to access, and it has a description here for how to do that. And then you want to add a link to that shared folder in the users directory. And as well, you can create another directory where students can share files with each other. So it goes through that. Let's see. So the install is done here. I'm going to go back to this notebook. I'm going to restart the kernel. And now when I execute this, the packages are imported just fine. And I can go through and I can check this. Let's see, I'll just copy this in. And so it's executing things just like we saw were being executed in Deep Note. Another thing you might find interesting to try out, you can initialize this to launch them directly into Jupyter Lab rather than, this is kind of the classic Jupyter environment. If I come up here and I change this word tree to lab, it will launch me into the Jupyter Lab environment rather than the classic environment. So here also I could, well, I'll close it here. And I'm going to exit out of the terminal. I'll open this up. So there are a lot of nice kind of user interface things with Jupyter Lab that aren't available in the classic environment. Although if you like an environment that's just a little more spare, the classic environment is really nice because it kind of eliminates all of the clutter with the menus and all that stuff. But here, for example, once this finishes loading, you'll see, for example, that the click here to check your understanding is now has the little arrow thing. There are icons that appear on the cells that allow you to copy it or move the cells and delete them. So the Jupyter Lab has some additional user interface features to it. Let's see. Kind of there's a lot that you can customize about the environment. You know, so I invite you to read through these how-to guides if you're really interested in some more customization. But I was able to set this up relatively quickly, and once you got used to what the steps are, this would hardly take you any time at all. So it's really easy to spin this up. You can spin it down just as easily by coming back here and on my over here. Oh, sorry, I have to move my windows around. Over here on these three little dots, you can stop this virtual machine that you started up. You can completely delete it. You do want to make sure that if you're done using the JupyterHub, or if you're done with your class and you want to get rid of the accounts, at whatever stage it is that you decide that you don't need this running anymore, you want to come back and you want to stop and delete it, because you don't want things just running here continuously, or else the cloud is going to charge you to keep on running things. We haven't really set a lot up, but it's not hard to all of a sudden realize that you've spent a whole lot of money running things on the cloud. So I put a reminder here about this because this is an important point. You don't want stuff running that you don't need to have running. On this next page, I've included a link to a nice page that Berkeley put up about choosing between several different kind of JupyterHub infrastructures, or JupyterHub similar infrastructures. What I was showing you was called the littlest JupyterHub. So this is, you can think of as just running on a single computer, although it's running on a cloud instance. If you want to go to a number of users where you might exceed 50 or say 100, that's getting into the stage where you probably want to have multiple of these instances running and being able to accommodate having a lot of users kind of intermittently log in and then an hour later log off. And you want to be able to spin up how many resources you have running at any one time. And if not a lot of people are logged in, you want to spin that number back down so you don't have more resources running than you need to. So the littlest JupyterHub is useful for, actually, this littlest JupyterHub for under around 50 people, kind of due to the capacity of single machines. What I set up at UCLA, or with this this other project I mentioned about data science and statistics, that has several thousand users that can be logged in any given week. So when you approach something like that, then you want to use this tool called Kubernetes, which allows you to kind of orchestrate how all these instances are spun up and then spun back down. So you can get into a more sophisticated deployment with this JupyterHub for Kubernetes. And then this page also talks about Colab. Azure is the Microsoft offering. I can talk more about Binder if people are interested, but Binder is kind of like JupyterHub. And then there's also, it talks about local Jupyter Notebooks and Visual Studio Online. So on this page, I'm not going to go through it very much, but you can look at it later. It gives you a sense of how they compare in terms of cost, how much you can customize it, what's required to deploy it, kind of the scale that it accommodates. So here's the littlest JupyterHub. It allows you to try and estimate how much, say, memory and CPU and disk size you need. It has estimates for costs for different class sizes. And then there are costs for the JupyterHub for Kubernetes, which is for much larger deployments. Costs for that, and then some frequently asked questions. And then quite a lot of useful links at the bottom as well. If you're interested more in those large scale deployments, there's a page that's similar to that littlest JupyterHub page that I showed, but it's called 0 to JupyterHub. So 0 to JupyterHub with Kubernetes is the documentation to consult if you want much larger deployments. So at this point, we could spin into just kind of some more free-form discussion if people are interested in more details. Just about what's involved with running the Jupyter hubs. I could also talk about Binder. Binder is essentially like a Jupyter hub that's publicly available for people to access. It doesn't keep a persistent file of the notebooks, a persistent copy of the notebooks, but it does allow people to interact with the notebooks. And essentially what it does is it initializes the user account and the user environment with the files and programming configurations that you specify in the GitHub repository. That may seem a little abstract at the moment, but I could show an example, of how to interact with a notebook with Binder if people are interested. And kind of some final notes. If you get more involved in these configurations, I do recommend that you investigate version control and continuous integration. Specifically because you'll probably want to have some place where you store a history of all of the versions of your configurations that you go through, just so that you don't forget what you've done. Making all of these details can get complicated, and then it can be even more complicated if you think that something worked previously, but you can't remember exactly what it was. So version control will allow you not just to store your configuration, but kind of store the history of all of the modifications you've made along the way. Continuous integration is something that's useful for kind of archiving your workflow and automating it. So if you have a given workflow, like what I was setting up for the the VM instance, you can automate that entire process so that when you kind of tweak some parts of the integration or of the configuration, then you can use continuous integration to just automatically run through the entire deployment process again for you without you having to manually go through and do all the steps again yourself.